Hello everyone. Today we are thrilled to present our MPMC project, a smart access control system that uses an Arduino microcontroller, an RFID reader, and an L290 motor driver to control a solenoid lock. Here's a quick breakdown of how it works. The first system is power activation, where when the system is activated, the motor driver powers the solenoid lock. Second step is unlocking the door. The solenoid coil energizes, creating a magnetic field that pulls in the armature. This extends the plunger, unlocking the door. Third step is access granted. With the door unlocked, the lock opens and then the entry is allowed. Now the next step is locking the door. Once the Arduino signals the driver to stop, the solenoid lock power is cut off. The magnetic field collapses, allowing the spring to retract the plunger and hence securely locking the door. This project demonstrates how an Arduino microcontroller combined with an RFID reader and motor driver can effectively manage secure access. It's a simple, effective, and adaptable system for real-world use in areas requiring control access.
Hello everyone, my name is Jairus Solomon and today I'm going to explain the procedure and working of our MPMC project. The main component is the Arduino Uno R3 microcontroller. It uses the 80 Mega 328P microcontroller, which is a 8-bit microcontroller, has a flash memory of 32 kilobytes, operating voltage of 5 volts, clock speed of 16 MHz, and has 14 digital input-output pins. The next component is the RFID sensor, model number MFR-C522. It has a 13.56 MHz operating frequency, uses the SPI interface for its communication, voltage of 3.3 volts, and the detection range up to 5 centimeters. It also uses low power consumption. The next component is the OLED screen, model number SSD1306. It has a resolution of 128 into 64 pixels, has a high contrast display, uses the 12C or SPI interface, and has an operating voltage of 3.3 volts or 5 volts. It is also very ideal for embedded systems. The next component is the motor driver, model number L298N. Has a dual H bridge driver, controls DC motors and stepper motors, operating voltage of 5 volt to 35 volts, has a built-in heat sink, and an output current of 2 amps per channel. The next component is the motorized solenoid door lock, which we have used for our project, along with breadboard and jumper wires. Now I will explain the code used in the module. The first step is the setup. So in this step, we initialize the serial communication, RFID module, and the OLED display. We also configure the digital pins for the solenoid lock control. We also display a prompt to scan the first tag. The second step is the loop. So we check for a new RFID tag, reads the first tag UID and converts it to a string. The first tag is the valid tag. If no valid RFID is registered, saves the current UID. If the scanned RFID matches the valid UID, activates the solenoid lock for 2 seconds and also displays a success message. If the scanned RFID does not match the valid UID, it displays an error message. Here, UID stands for unique identification. RFID detection. We use the MFRC522 library to read the RFID tags via an SPI interface. The register registers the first scan tag as valid and stores its UID. Compares the subsequent scans to this valid UID to determine if the tag is valid or invalid. The OLED display uses the ADF root SSD1306 library to display messages such as valid RFID UID and scan status. Control output activates a solenoid lock or similar device by setting a digital pin valid RFID when the valid tag is scanned. These are the libraries and pin definitions. So the SPI.h library facilitates communication between the Arduino and the RFID module. The MFR-C522.h provides RFID specific functions. The wire.h is used for I2C communication. ADF root GFX and ADF root SSD handle the OLED graphics. The SS pin and the RST pin, which is a reset pin, is used for SPI communication with the RFID module. Valid RFID pin controls the solenoid lock. So this is the code for the setup function. It initializes serial communication for debugging, initializes the RFID reader and OLED display, configures valid RFID pin as an output, displays a welcome message on the OLED. This is the loop function. So this function basically checks for a new RFID. If present, reads its UID and converts it to a string. So the first RFID tag that is registered is the valid tag and it stores its UID. So this is the code for the first RFID. If no RFID is registered, the valid RFID is set to a blank and the current UID is stored as the valid tag. Displays and logs the valid UID. So now this is the loop for checking the subsequent RFID scans. So if the scanned RFID matches the valid UID, it activates the solenoid lock by setting the valid RFID pin high for 2 seconds. So the solenoid lock is unlocked for 2 seconds. It also displays a success message. If the RFID module is invalid, it displays an invalid RFID message. So this is the code for continuous reading to stop the continuous reading of the RFID sensor. Once the power is on, the OLED prompts the user to scan an RFID tag. The first tag scanned becomes the valid tag. For the subsequent scans, if it's a valid tag, it activates the solenoid lock for 2 seconds. Else, it shows an error message. Thank you.
So this is our setup and the Arduino controller, the RFID scanner, the motor driver along with 3 batteries, the OLED screen, the solenoid lock, and 3 RFID tags. It's also being connected to a power source. So we reset it. I take one card as the first scan. So now that is the valid scan. So it says on the OLED, first RFID registered. So now that is the valid tag, and as you can see, if I put it again, it unlocks for 2 seconds and unlocks for 2 seconds and locks. So if I pick up another card which is not the valid RFID, it doesn't unlock, and the OLED shows a message saying invalid RFID scanned. Another RFID which is not the first one, so it's an invalid RFID, does not unlock and shows the error message invalid RFID scanned. Once again, if I scan it with the valid RFID, it unlocks for 2 seconds and locks. Also, the OLED shows valid RFID scanned. So this is our MPMC project. Thank you so much.
Thank you for watching our presentation on this RFID-based access control block. This system demonstrates how we can leverage RFID technology and Arduino to create a secure, adaptable, and user-friendly access solution application. Our project could be implemented in numerous real-world scenarios. For example, office spaces. It can manage secure entry, allowing only authorized personnel to access certain areas. Residential use. Homeowners could use this as a keyless entry system that automatically assigns access to new users. Future possibilities. Building on this foundation, there are many directions we could take. Logging, entry, and exit. By adding data logging, the system could record each access again, allowing for entry tracking and enhanced security. Multi-user access levels. We could expand the functionality to allow for multiple levels of access by categorizing cards with different privileges, such as admin, staff, and guests. Remote management. Adding Wi-Fi or Bluetooth module would enable remote management, allowing users to authorize new cards or remove access from mobile app or web interface. Enhance security with biometrics. Integrating fingerprint or facial recognition would improve multi-factor authentication, further securing sensitive areas. In summary, this product is just the beginning of a wide range of possible applications and enhancements. By combining RFID technology with microcontrollers, we created a flexible, expandable access control solution. Thank you.